Hi, welcome to Code G. My name is Nishant, and today we are going to study mathematical logic. To begin with logic, the first thing that I'm going to introduce you with is propositions. So, a proposition is an assertion or claim that is either true or false. So, there is nothing in between. For example, 2 is an odd number. Well, this is false. Or what about 3 is an odd number? Well, this definitely is true. You go anywhere in this world, if you tell them that 3 is an odd number, they'll be like, okay, that's true. Or in general, example can be sun rises from east. Well, this is true. This is true for everywhere, right? What is not a proposition is a statement which is vague, which is sometimes true and sometimes false. Like, dogs are brave. My dog isn't brave. Maybe yours is. My dog isn't. So, it may be true for some cases and may not be true for some others. So, this is not a proposition. Okay, so now when we know what a proposition is, let's define what the negation of a proposition is. So negation of a proposition, let's call the proposition P, is just if you negate the statement. Okay, so suppose here we have an example P, A is a consonant. So the negation will be A is not a consonant. We just negated it. Or for say we had an example in the last slide where we said suppose Q is 2 is an odd number, right? So the negation of Q is going to be 2 is not an odd number, right? So not Q is true. 2 is not an odd number, that is true. But this was false. Okay, so now when we know what the negation is, let's define what an implication is. So implication is, suppose you have two propositions, P and Q. So P is one proposition and Q is another proposition. So we say if P then Q is an implication. So suppose P is a proposition, a person is healthy, and Q is that person is breathing, right? So we can have an implication. If a person is healthy, then he is breathing. Well, this is true. If a person is healthy, then he's definitely breathing. There is no way he's not breathing and he's healthy. He'll probably die, right? The other example can be if x is greater than 2, then x squared is greater than 4. Well, definitely, right? This is suppose x and this is y is equals y. So we have y is equals to x squared, something like this, right? So when this is 2, this is 4. Well, this is not definitely 4, but you get an idea, right? So if this is true, then this is 4. I'm sorry for that. And when this is 3, then this is definitely greater than 4, like 9, right? So this is also true. Now let's move on to some terms that is usually you might find them in your economics books. That is necessary and sufficient conditions. So now going back to the implication thing, if P implies Q is true, then we say P is sufficient condition. This is important. If P implies Q is true, then we say that P is a sufficient condition and Q is a necessary condition for P. So think of the example that we used earlier. If a person is healthy, then he is breathing. So, person is healthy is a sufficient condition for that person to be breathing, which is true. The person is healthy, definitely is breathing. And we can say, hence, this is sufficient. This is sufficient for us to know that the person is breathing. If he is breathing, then it is necessary for him to be Now, suppose this proposition is true. If a person is healthy, then he is breathing. We will say that, the person breathing is necessary for the person to be healthy, which is right. I mean, if he's not breathing, he'll probably die, right? So it's necessary for him to breathe to be healthy. Okay, so this was it for the basics of logic. Now let's move on to set theory. Set theory, you might not probably use it directly, but in problems where using probability, or where I'll be telling you about functions in depth, you will figure out why knowing set theory is really important. So, set theory, what is a set? A set is a collection of distinct objects. So, suppose you went to a parlor, game parlor, and you scored these points 8, 8, 9, 10, 11. So, you played in all 5 games and you got these points. So, what is the set that consists of the points that you scored? It will be S is equals to 8, 9, 10, 11. Whenever we talk about set, we talk about distinct objects. So there is no repetition. Now, for some examples can be set of natural numbers, that is 1, 2, 3, 2, dot, 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 down, n, infinity, right? The other example can be A is equals to 1, 2, 3, 4, B is equals to 2, 4, 6, C is equals to cats, dogs, rabbits. D is equals to maybe your favorite superstar like Salman Khan, Amir Khan, Bobby Deol. Bobby Deol हो सकता है, किसी का हो सकता है. Don't laugh. Complement of a set. So before I begin telling you complement of a set is coming from a universal set U. So suppose U is minus infinity to infinity. This is all the possible numbers. And A is your 1, 2, 3, 4. So A complement will be everything that is not in A, right? So it will be minus infinity to 1, not included, union 4 to infinity. And here I would mention that suppose that these are integers. Okay, so this was complement. And about membership. So we say, so remember, okay, so we say, remember we had an example A is equals to 1, 2, 3, 4. So we say that 1 belongs to A, or 2 belongs to A, or 3 belongs to A. This sign, this means belongs to, which tells you that 3 is a member of A, right? What is a subset? Subset, suppose that you have a set B is equals to 2 and 3. So B is a subset of A, which means that every element that is there in B is also in A. Okay, so in definition, every element of B is present in A, then B is a subset of A. Okay, so now let's move on to set operations. A union B, which is denoted by A union B, it means that all those elements that are either in A or in B. So suppose, let's begin with the example that we had. Okay, A is equals to 1, 2, 3, 4, and B is equals to 4, 5, 6. Okay, so what is going to be A union B? A union B is going to be 1, either in A or in B. So 1 is in A, 2 is in A, 3 is in A, 4 is in A and B, both. So, the condition is for an element to be in A union B, it is either in A or B. So 4 is in both. So it will also be a part of A union B, right? 5 and 6. So this is your A union B. Now, what is A intersection B? Intersection means it is in A and in B. So it's in both. It is denoted by this sign. So here only 4 is a part of A and B, right? So A intersection B is going to be 4. Now what is A minus B? This thing is denoted by this sign. It is also said like read as A not B. Okay, so it means that the element has to belong to A but not to B. So 1, 2, 3, 4. Out of these elements, 1, 2, 3 belongs to A, but 4 also belong to A, but 4 is also in B, and we do not want that. So A not B is equals to 1, 2, and 3. To understand, to understand set theory in a better way, there is an amazing approach which is called a Venn diagram. Now I'm going to talk about this Venn diagram. So now let's talk about what a Venn diagram is. So suppose you have a universal set, something like this. Okay, it's a rectangle. Forgive me for that. And you have a set A, and you have a set B. So what if I ask you what is A union B? So for A union B, if we go by the definition, which is that the element that belong to at least one of the sets, okay, one of the sets A or B. So A union B is going to be this whole part, right? So this is going to be your A union B. What is going to be A intersection B? So let me write here, this is A union B. What is going to be A intersection B? Well, if this is A and this is B, A intersection B, remember, it the element has to be in both A and B. So the only elements that are in both are these, right? These are a part of A and a part of B. So this is going to be A intersection B. Well, what about A but not B? Well, suppose you have this A and this B. So the elements that are in A but not in B. So these elements, they are also part of B. Even though they are a part of A, but they're also part of A. You don't like them. So A minus B or A but not B is going to be this part. Okay, this part is not included. The darker region that I've shaded, that is not a part of it. Here is your A but not B. Okay, I think this was it for the set theory, guys. The next topic that I'm going to tell you is going to be functions. Until then, see you next time. Bye.